Good morning to everybody. Myself, Dr. R.C. John, Associate Professor, SPC, Government College, Kashmir. Today we will discuss MSc Physics Semester 2nd, Paper 5th, Classical Electrodynamics and its Unit 1st. We will continue the topic, that is wave propagation of the electromagnetic wave in conducting medium. Yesterday we have calculated the phase velocities, refractive index of the medium by using the wave equation in a conducting medium or the dissipative medium. Topic for today is the depth of penetration, that is the skin depth and the Poynting vector, and the impedance of the medium. So first of the all, we will start the skin depth or the depth of penetration. What is the definition? What is the introduction for this one? That is the depth of penetration. For a conducting medium, the wave suffers attenuation as it progresses in the medium. Example, at the high frequency, the good conductor have the high value of the sigma, that is the conductivity. So the omega sigma is very high for such a wave, due to which the attenuation coefficient, the alpha equal to the root of the omega mu sigma by 2 will be also the high. So if the frequency is high, sigma is high, then the attenuation coefficient will be also the high. So the wave of such type of the wave in the medium, conducting medium, will be attenuated more, or it is absorbed as earlier as possible. So the wave in conducting medium is rapidly attenuated. Means the intensity will be decreases as the depth increases inside the medium. So what is the definition of the depth of penetration of the skin depth? We can define the depth in the medium or the distance in the medium in which the wave attenuates to the 1 by e times of its strength at the surface of it. Means the 1 by e times of the initial intensity decreases, then this value is achieved at the penetration depth. Inside the medium, wave is propagating, then a particular distance, that the intensity remains only the 1 by e of the maximum, that the incident, that is called the skin depth. How it is calculated? For this one, we start the numerical values to derive it. Let E0 is the electric field strength at the incident of the surface of the medium, means that is the incident value of the electric field at the surface of the medium. Then at the z distance, the value of the electric field. Here we have calculated that the wave is propagating along the z directions, plus z directions. So at the distance, you can write Ex equal to the E0 minus alpha z. The alpha is attenuation constant, z is the distance. So what is the relation? This shows that the distance is increases inside the medium, the electric field values decreases exponentially. And the definition of the skin depth, we can write Ex equal to E0 by at the z must be equal to the skin depth. So using these two equations, we can obtain that the alpha z equal to the 1 for this case. So the z equal to 1 by alpha, and this z, that is the delta, called depth of penetration or the skin depth. So distance traveled by the wave in the medium. So we can obtain this del equal to 1 by alpha, and this is substitute the value of the alpha, that is equal to the del equal to root of the twice omega mu sigma. So this gives the skin depth or the penetration distance. So we can conclude that this depth of penetration depend on the mu, omega and the sigma. Mu is permittivity of the medium, omega is the frequency of the wave, and the sigma is the surface charge, that is the conductivity. So all have the inversely proportional of the root of these values. So for example, sea water is the poor conductor. So the radio communication, because it is the lower value of the delta, because this sigma is the high, then this delta is low. Good conductor, the sigma is high, del is small, so they are opaque for the light. Third, the thin film, that is the sheet of the conducting material, is the behaved low pass filter for the electromagnetic wave. Means it here the low frequency can be passed through this one and the high frequencies are transmitted. They can be stopped by this media. And then the second topic for today is the impedance of the conducting medium. So we have calculated the skin depth and now it is the impedance of this one. As per we know that the characteristic impedance is the ratio of the electric field to the magnetic field, and earlier we have calculated if the wave is propagating along the z directions, then the electric field is along the x-axis and the magnetic field along the y-axis. So we can write the value of the electric field at the position x equal to the Ex star equal to the E0 e raised to power minus gamma z plus iota omega t. Ex star is the complex electric field. Here the star is used for the complex, means that have the real and imaginary part. Similarly, the magnetic field vector is Hy because it is along the y-axis, so that is Hy star equal to the H0 e raised to power iota omega t minus phi minus gamma z. Here minus phi. This so that the phase difference is there in between the Ex and the Hy. Here this Hy is lags behind the Ex. So we can write the impedance by the dimension of the impedance Z star equal to the Ex star by the Hy star and magnitude of these two. Substituting the value of these two, we can obtain E0 e raised to power iota omega t minus gamma z divided by H0 e raised to power iota omega t minus phi minus gamma z. So the all exponential components are divided. Only is there in denominator, there is e raised to power minus iota phi. So we can write Z star equal to the E0 by the H0 e raised to power iota phi, or E0 by H0 is Z0 e raised to power iota phi. Z0 is called the magnitude of the intrinsic impedance of the media. So this will be so that there is the phase difference between the Hy and Ex is the phi. So phi is called the phase angle. Now the other form of the impedance we can calculate in terms of the frequency, that we use the Maxwell equations. The third Maxwell equation is that del cross E star equal to minus del E star by the delta t. If the wave is propagating along the z axis only, then we say Ez star equal to 0, Hz star equal to 0, and also now variation is along only the z axis, so we can write del by del x equal to 0, del by del y equal to 0. So the electric field in the x only with the Ey equal to 0 and the magnetic field along the y-axis only, so the remaining component is 0, Hx star equal to 0. So to calculate the values, we use the third equation Maxwell's, that is del cross E equal to minus del B by del T star. So in terms of the determinants, we can write Ijk del by del x is equal to 0, del by del y that equal to also 0, and third one that is non-zero equal to del by del z. The component of the E is along the x-axis only, so Ex star 0, 0. And similarly for the magnetic field, that is only along the y-axis, so that why only the component is Gpy is 1, 0, otherwise all the two component remaining, that is the I cap multiple and the J cap multiple is 0. So on comparing these two terms of the J cap on both sides, we can write J cap del E star by the del Z equal to minus of J cap del By by del T right hand side. So we can say del E star x by the del Z equal to minus del B star by del T, and as earlier we have write By star equal to the B0 e raised to power iota omega t minus phi minus gamma z. So this gives del By star by del T equal to iota omega By star, and then the star Ex star is also differentiated with this one, with the Z that is equal to del E star X star by del Z equal to minus gamma Ex star. So substituting the values of these two, we can obtain the Ex star by the Hy star equal to the J omega mu by the gamma, and this gives the Z star. So for the intrinsic impedance of the conducting for the good media, we can have calculated earlier that gamma equal to 1 plus J, that is iota, root of the omega mu sigma by the 2. So Z star equal to J omega mu by the gamma. We have substituted the value of the gamma, we can obtain this one, and the rearranging this one, because 1 by J is in denominator, so it may be rises up, and this is can be obtained by the multiplied by the 1 minus J only on both sides. So you can write like this one, Z star equal to the J minus J star X square, and the omega mu divided by the 1 minus J square multiplied by the root of the omega mu sigma by 2. And rearranging, we can write, because J square equal to minus 1, so this gives the 1 plus J numerator omega mu, and in the denominator we can obtain 1 minus 1, so this is the 2 root of the omega mu sigma by 2. So Z star equal to 1 plus J by the root 2 of the omega mu sigma. And here, because this is Z star is a complex quantity, so it has the real and imaginary components. Real component is Z cos phi, and the imaginary component is J cap Z sin phi. So on comparing these two, we can obtain Z cos phi equal to the root of the omega mu by the 2 sigma, and the Z sin phi equal to the omega mu by the twice sigma. But so this tan phi equal to the 1. So Z equal to root of the omega mu by the sigma, and angle is 45. So for good conductor, we can conclude that sigma is quite large, so the Z star equal to the small. Second, the phase difference between the Hy and Ex is 45 in the good conductor medium. And third one, the E leads H by the 45. This currents which is responsible for H is the conductor in the conducting current. And the last topic for today is the Poynting vector in conducting medium. As earlier we have known very well that the Poynting vector equal to the E cross H. So let us consider the EMW is propagating along the Z-axis, and its electric field is along the x-axis, and the magnetic field along the y-axis. So E vector equal to the I cap E0 e raised to power J omega t minus gamma z. As earlier we have write, and this gives iota I cap E0 e raised to power J omega t minus alpha plus J beta, because gamma equal to alpha plus J beta. Rearranging this one, I cap E0 e raised to power J omega t minus alpha z minus J omega beta. So this can be written I cap E0 e raised to power minus beta z e raised to power J omega t minus alpha z. And similarly for the H, we can write J cap E H0 e raised to power minus beta z e raised to power minus iota omega t minus alpha z minus phi. But Poynting vector P equal to the, we can write E cross H. So on differentiating this one, taking the gradient of this one, it is divergence, sorry. So the divergence of this one is del dot E cross H. So this gives the H multiplied by the del cross E minus the E multiplied by the del cross H. So we can write by using the Maxwell equation, del cross equal to minus del V by del T, and the del H equal to del D. Using this one, we can write del D by del T plus J vector by using the fourth equation. So this gives minus of the del by del T of the 1 by 2 mu H square plus 1 by 2 epsilon naught A square bracket close minus E dot J. Using the Gauss theorem, divergence theorem, we can write del dot A dV equal to del dot ds, that is converting the volume integration into the surface integral. So this can be written like this one. So del dot E cross H dV equal to the del E cross H into the ds. Remaining factors are the same. So the finally Poynting vector equal to E cross H can be calculated by using this formula. So this is about the Poynting vector. So today we have calculated the 3 important points. first we have calculated, that is the values to calculate skin depth or the penetration depth, and second one the impedance of the medium, and third one that is this one, that how it lags behind this one and the leads the value and the pointing vector, that is the energy flow per unit area per unit time. So this is sufficient for today. Thank you very much.